Tell me about yourself and how you started as an aerospace engineer.
I used to be aerospace engineer, but now I'm developing my own company. I'm running my own startup. I think the idea to become aerospace engineer struck me when I was a kid because in Soviet time we had those books with lots of space stuff and different encyclopedias, other things, and I was amazed. And my parents are engineers, almost all except my grandfather, who wasn't an engineer, but he had intention to become one. But anyways, my childhood determined my path towards engineering, but since my parents were civil engineers, I decided to go further, to go to space stuff, and it was a romantic decision. I applied to National Aerospace University, which is Kharkiv Aviation Institute, and after graduation, I began working in Ukrainian biggest space company, probably the single one, the State Design Bureau Yuzhny. I worked in the design department. It was specific design department because we've been working on different stuff, like lots of different subsystems to space systems, space debris removal systems, some very crazy things like space elevators in terms of research, basically. But also working on more, how to say, close to the ground things like rockets, launch vehicles, which were part of the common routine in our company. But basically, I was always working on developing new stuff. My career, my 10-year career in design bureau, it was mostly turning idea into some viable concept, validating this idea, like making some computations, calculations. I used to call it mathematical modeling. Maybe it's the broad term mathematical modeling encapsulates many things, but this was the part of the whole mathematical modeling thing is when you try to apply physical laws, apply design methodologies to validate some idea, to drive some innovation into the shape that it can be recognized by others and it can go further into development. Yeah, this was my path as engineer. I was involved in moon-based components development, other things, very cool things. But over this whole career, I understood that we have big problems in engineering, especially when it comes to turning idea into some concept. So engineers always use drafting, even if we talk about 3D modeling, they use I would say, old approach, the same as they have been doing many thousands of years. They have some idea of the system and they start drafting it, start building models. But in the essence of this process is you missing many variants of these things because you're focusing on one specific design. And this is essentially due to the lack of knowledge in engineering. I'm talking about knowledge that is easy to reuse, to re-implement. When you're building a mathematical model of something, you rely on some existing knowledge. And it is important that you are able to reapply this existing knowledge to validate your concept and many different concepts that you have. And so I realized that there is a big problem in sharing this knowledge, in reusing this knowledge, and it's blocking engineers from being more innovative and being more creative. And so I decided that something has to be done about this, and I quit my job and I started my own company, started my startup. It's called Spline Cloud. So the whole idea of this startup is to develop a platform where engineers can exchange knowledge in a reusable form and facilitate each others with their ideas, with their approaches, with their calculations, simulations, with tests, so others can benefit of that and make the path from idea to design shorter. So this is it.
Was there like a specific example of a project or a specific concept design that you were working on? Then, after some years, you would realize that if I had this platform that year or for that project, I would just do it much faster because somebody else already shared that idea or tested that, and you would just reuse the knowledge. Is that how it works?
Different ways, but this is one of the ways. So I would say that I tested different approaches in engineering. If we go back to how engineers design things, they use methodologies. They use some empirical laws. This is a laws that are obtained from experiments, maybe some tests statistical data, other things. And they develop algorithms actually, how to design things. Those algorithms, you can find them in the handbooks, and they explicitly say, okay, this is the formula for this thing, this is the formula for this thing. Now we have derived this function, and based on this function, we can do this. Basically, the whole approach of designing things is in building these methodologies and building these algorithms to design new products and maybe systems. And this is the old approach, and this approach was used many years to build spacecraft, to build aircraft, to build anything in engineering, motors, engines, other things. And since I've been working on designing different things, I was always faced with this necessity to find the right methodology or to develop your own methodology and to come up with some concept, with the mathematical model or maybe the 3D model of some system that is based on these rules and this methodology. I intentionally went out of my frame of knowledge in aerospace. I shifted a little bit towards electrical engineering, so I decided, okay, let's find out if the same rules are applied in a little bit different domain of engineering, not aerospace engineering. I found out that this the law is the same. There are design methodologies how to design electrical motors. And I wrote my own methodology using, but by that time I was using Maple, which is the system for mathematical modeling. So I used this system to implement the design methodology of electrical motor into the program that would find the essential design parameters of this motor. And then I was shifted back towards my domain, aerodynamics, and I wrote the very similar approach, but for designing the aircraft, right? Then I realized that, okay, this is basically the concept. And during this, finding these methodologies and implementing these methodologies into computer code, you often use with some data, statistical data, some knowledge from books, some graphs, some tables. And this is how I came to the idea that we need to find out the way to efficiently manage this kind of data in engineering, like graphs, tables, so that you can basically turn the whole process of writing, re-implementing this methodology into more simple process, and you will just reuse existing graphs, tables, not do the same stuff again and again.
You mentioned that it's not only for engineers, it's for scientists as well. So it works the same in science in very specific niches where you can use it. How does it work for scientists if it's not maybe I don't know if it's like engineering also counts as science if it's you consider the space science?
Yeah, it's funny because we have debates like if engineering is a science, and there are lots of names like are engineers actually scientists? I would say it depends on the extent towards you go in your engineering career. So if you're doing some basic things, hardly you can tell about yourself as a scientist because you use simple formulas, simple methods. But the farther you go, the more complex things you're working with. So it becomes a science. I would say engineering is not only science, also it's art because you have to have an ability and skill and experience to understand where are the measures which you can neglect with something, which are the measures that you can adopt something, and which are the measures going beyond which you will have wrong results. So in science, it is always the path of finding perfection, finding right model of the universe, maybe, right? So in physics, you go and try always to derive some equations that will be more precise, more accurate. In engineering, it is a little bit different. It's more about finding compromise of time and accuracy. This is the difference between science and engineering. But I would say that answering your question, these approaches are really applicable towards science because engineering is based on science. It's based on scientific laws. It's based on scientific approaches. So in science, if you are working, for example, with, I don't know, maybe processing results of maybe some accelerator of particles or I don't know, some crazy scientific stuff, you always use methods, mathematical methods to find maybe approximation of some results, find flaws, functions, to process data, lots of amounts of data, and derive some methodologies how to test this thing another day. So science and engineering comes hand in hand. I would say it's very related, but as I said, the goal is a little bit different.
Then, if there are like a lot of people that don't know about your platform, how to access it, and can you explain what kind of struggles they might have to just go there and try to figure out how it can help them, whether they are working on specific, do they need to work on specific project, do they need to just be a student and they're working on their thesis and just want to like to find some answers, or to just add some of the already known projects and known science, or how that can be explained to people that never seen how it looks.
I really don't have the right answer to that because currently I'm struggling with my go-to-market, I would say, strategy, maybe go-to customer strategy, and finding the right way to explain the benefits of using Spline Cloud, using the approach. But the root of all this, I would say it goes towards the, so they say, knowledge-based engineering approach. I was really interested in this approach. This is a little bit different from what I described as engineers are doing in the old-fashioned way. So I would say SplineCloud can benefit significantly those who are willing to apply knowledge-based engineering approaches in their design. So talking about knowledge-based engineering, I would say this is a very old approach. It's 30 years, maybe more old, and it was developed in early times in the 80s probably, where engineers understood that doing routine stuff is not like very cool thing in engineering. Redesigning things, for example, you are designing a wing of airplane, and you have to re-implement some simple things like you increase the number of ribs, maybe you increase the size of this wing, you add some winglets to on the ends of the wing, other things. And doing this in a classic traditional way using CAD systems, which is computer-aided design for 3D modeling, requires you just drawing same thing different ways again and again. And it was realized back in those days that some automation can be applied here. Now we are talking about going beyond just methodologies of designing things, but also about automation of design. And the whole process of automating design was based on building expert systems, which are actually programs that design things. And those methodologies are actually encapsulated in those programs. And this whole knowledge-based engineering approach is focused on knowledge, on encapsulating knowledge in your design and reusing this knowledge. And I would say going towards students and universities and engineers right now with Spline Cloud, I'm trying to explain the value of knowledge-based engineering, how it changes the perspective, how engineers design, how you should be focusing not on the design as itself, but about on the knowledge about designing things and how to convert this knowledge into program that generates designs. Now, this is a little bit shifting you from being mechanical engineering and then drafting things towards being a more like a programmer and program things that are, yeah. And so I try to explain this message, explain the value of this approach, and I created a demo project, which is the generative application which generates wings of aircraft, maybe unmanned aircraft. And this is a use case where data from Spline Cloud is used by the program and it runs. So for the user who inputs desired aerodynamic profile of the wing and size of the wing, it goes to Spline Cloud, finds the airfoil and its properties, pulls it down into this program and calculates aerodynamics, stress, other things. So you have all automated design of the wing, and you can iterate it over and over again by just inputting what you want from this wing.
So if using your platform, I can test my design or like modeling. If I want to change something in the wing, in the design of the wing, and then you would tell me this how it would work if I would put like a bigger size or.
With one exception, you have to write your own model for this. So you can use models that there are out there, but the idea of Spline Cloud right now is providing a database for very basic engineering knowledge that you can use in these models that you can build yourself. For example, if you want to, I don't know, design maybe some motor, maybe engine, right? You would use existing methodologies that are written in books, and but you would need some data about materials. You would need data about what the stress analysis of some parts maybe that you can find on Spline Cloud, or you can create your own repository with this data so somebody else will reuse it. But basically, the idea is yes, you can create this application or find the application created by others and reuse it in very basic, simple way, just inputting what you want from this design and obtaining 3D model with all parameters. So this is the idea. And with SplineCloud, we're trying to facilitate the ability to create such applications. You can create those applications based on the open source projects. You don't need proprietary software for that. But the knowledge base is essential, and we are focusing on building the knowledge base for that, the distributed knowledge base where everybody can contribute.
You started working on that during COVID times, right? In 2021. I think it's been already 3 years that you've been working on it. When you just started thinking about it and when you actually started working on it, how long did it take for you to actually just, okay, I'm just going to work on it. I'm not going to think about it anymore, just do it?
Yeah, the path was really tricky, long, and wavy. I would say the idea came to me like in the early times, maybe in 2015. So it was incubating in my mind for quite a while. So I was testing various things and I was trying to find the answer what would be the minimum viable product and what would be the essential tools that are required for somebody to facilitate the ability to create these mathematical models. So I came to towards understanding that engineers and scientists mostly do the routine things when they process an existing data. They either digitalize data from papers, from scientific papers, from some catalogs, from test results, and it comes. Nobody will tell you, but this is thing that everybody do in terms of engineers and scientists. They usually try to extract data from graphs, and this is very popular thing that they do, but they never tell about this because they are busy with more interesting things like 3D modeling and numerical analysis, and they would always talk about problems in numerical analysis, but never talk about extracting data from graphs. They do this. And since you have this extracted data, then you try to feed some function to that data. And this is also, it's known like curve feeding. Yeah, I decided that I should focus on these two tools and which are currently implemented in MVP. So the path was like, okay, I have this idea of MVP. I started it drafting piece by piece at night. And in 2021, I decided, okay, I shouldn't be doing this way. I should start going like a traditional startup. And I applied to a business incubator with my ex-co-founder. So we have been struggling with validating this idea many times through engineers during the say 4 month program. So yeah, it was 4 month program. And we participated in some conferences, local business conferences, in some contests. So yeah, it actually started to gain momentum. I had some proposals from investors, but and we actually received a grant funding from Field Dev Global, which helped us to develop the MVP in terms of like viable service, not just a demonstrator that I have had by that time. So yeah, it was running pretty quickly, but then the war started, and all investors said, okay, we had intention to invest in you, but let's wait for some time when the water will be calmer. And so since then, I've been bootstrapping and improving step by step the platform, improving solution, starting marketing attempts, doing search engine optimizations, writing articles, talking to people, participating in some conferences, making webinars. And as of now, I would say we have like constant sign-ups on our platform. People are testing and using it. And right now, I'm starting partnerships with universities. Last week, I've been working in the National Aviation Institute. I was talking about knowledge-based engineering, the value of this approach, and they're very interested in implementing it in the university, trying out maybe through coursework of students, maybe through some thesis works, maybe somehow else. So yeah, this is the past 3 years passed, but I would say that this time that I've been bootstrapping, I validated many ideas in my mind that I have towards go to market strategy. Maybe it's not a bad thing that I had this time to rethink about how I would go further.
What about the knowledge base itself? Is there are there any parts of knowledge bases that you need help with of like people actually testing things? If it's you're talking about just aerospace engineering, let's say, or the universities that are very specific about the aerospace engineering, but what about other science niches? What about any other types of engineering? Do you need people to some specific people, some specific engineers to test their calculations to help you out?
Absolutely, yes. I would love to see many different domains of knowledge shared on SplineCloud because this is the whole process of engineering. You have to process and get access to what's knowledge from different domains and encapsulate it, incorporate it in your model, which you can, how to say, validate, improve, that you can make this model be more accurate. Currently, amongst the users on our platform, I have seen people not from engineering are those one cardiologist who are processing data from electric cardiology results. I don't know the term because I'm not a doctor. I have seen repository created with some tests of elementary particles. So probably somebody from laboratory that been made in tests of particle collisions or something else. I don't know because it's hard to understand what they represent this data. And yeah, I think that currently Spline Cloud is designed this way that it's not only applicable for engineers, but scientists as well. And it should be done this way further. But our core idea is to facilitate engineering because we want to, because this is our goal and mission. We want to drive innovation by enabling access to open and reusable knowledge. And innovation is usually related to engineering because science by itself makes no sense when it's not implemented in some physical work. And since we know about this problem and we have understanding about the solution that can fit to this problem, then we want to focus more on engineers. So our tools that we want to, new tools that will be implemented on the platform would be tools for engineers. But at the same time, we are open towards the general scientists. And if we have some ideas coming from them about maybe tools, maybe some improvements that can be made towards our platform that can benefit them, why not? That would be very
I don't know if you watched, there's a new show of Three Body Problem that's about scientists.
YouTube, always proposing me to watch something, but I haven't watched it because I know about this problem and I don't understand why I should waste time looking at that. But maybe something new was created there. I don't know.
It's just a show about scientists. They sent a brain to the aliens in a capsule and they tried to figure out how long it's going to take to get there. And they said, okay, it would be like 400,000 years or something. And then how do we speed it up? So all of the scientists with different backgrounds tried to figure out how to do that. So they used like nanofibers to create the parachute and the nuclear weapons to explode and speed up the capsule to get there using the nanofibers as a parachute. Like, and there's a lot of things just based on like scientific knowledge. So it's related. If you would just have all of that knowledge, it will be a bit easier for the group of scientists to test things, and they would make this modeling on in the computer to what could happen if this chain reaction of 1,000 nuclear weapons would react to the nanofiber parachute. So it's complicated, but then it's kind of cool. It's people would like come together as a group with completely different types of knowledge and just share their knowledge to create the project. So that was related to this is how you would use it, your platform for.
I get to know. I think it's really interesting. I have to take a look at this. But when you have like the video talking about like three body problem, you always think about astronomy, about the masses that interact through gravity, and it is known that you can easily solve analytically the problem of two bodies, but it is impossible to solve analytically the problem of three bodies. Maybe this is why they call it like that, because it's unsolvable problem. But
Mhm.
talking about the way, the extent of the reuse of existing knowledge in science and engineering, I like the comparison towards this artificial intelligence from Iron Man. I don't remember what was the name of this artificial intelligence. If you remember the movie, the Tony Stark had this artificial intelligence that was designing things on demand. So as a user would say, okay, I want this spacesuit like Iron Man has. I want to fly over, and this thing would go through existing knowledge in engineering, validate some concepts, uh, create, design this product, 3D print it, or manufacture it in other way, and voila, you have this suit. So this is the extent towards which we are looking at, and I think we are on the right path because the essential part of this is knowledge and the form of knowledge that can be used by artificial intelligence. And we're talking about formalized knowledge. We're not talking about knowledge that you can express in book when you read it and you have all these, how to say, flavors of maybe in this case somehow like the human type of knowledge, and formalizing this knowledge into tables and functions would allow artificial intelligence to efficiently go through these tables and functions, iterate over designs, and come up with something useful in meaningful with meaningful resources. Talking not about the artificial intelligence that would read these books, come out with their own
Mhm.
tables like they would do right now probably. This is something that would be implemented simpler and faster and based on reliable knowledge that is shared by people.
Do you have any specific goal for your platform or project in general? Like how who it's supposed to be used by in the ideally, and how it's gonna help people or maybe government or maybe what is the goal for it, where it should grow?
Let's say I would love to see technical universities using SplineCloud in their educational purposes, in their maybe in their design departments if they have them. And I would love to see engineers, young engineers, starting their own startups, beginning using the knowledge-based engineering approach and using the knowledge of Spline Cloud to derive some new designs, faster iterate over ideas. The goal is to make it kind of GitHub, but for engineers. For those who are not don't know what is GitHub, this is the platform for software developers, which you can call it different way. I call it the knowledge management platform. Most people say it collaboration platform, but it's not only about collaboration. It's about efficient managing the source code, the programs, the source code of programs. So I would say that we want to go to the scale of GitHub. This would be our winning aspiration to become the most powerful and most recognizable platform for engineers and make the same impact on engineers as GitHub made on software developers. Just because of the GitHub now open source idea is viable and it's everybody is winning from this ability to share the source code on GitHub. GitHub right now has like several tens of millions users, maybe more, I don't know. And this is our goal. We want all engineers and scientists to know about Spline Cloud, use it, and help each other to be more efficient and productive.
It's great. Thank you. I think that I can help you find some of those people that could start testing it. I think we can just make it work together. I already shared some of the ideas with you, and I think it's the easier way to start. It should be good to do the webinars for specific type of people. It's like very niche. So then you just talk in their language in meaning like specifically explaining some examples. So that should be cool, like showing how the platform works on specific examples or asking those people who already use it to explain how they used it and just be part of your webinar, which could be also like another thing. And
Great. That would be cool.
This sounds like a super cool idea, and even for me, that's I'm not an engineer even close, but we have so many new things developed in like short period of time, and now with the war in Ukraine, technology is developing like super fast, and even if it's war technology, it's but still the idea is that our people in Ukraine are getting smarter and smarter with days, and a platform like yours can be super valuable for people who are actually trying to understand how their idea can become like a live project.
I had like spreading the word about Spline Cloud would make it easier for people to understand the value that goes behind this platform and not only just the platform, but behind the idea of sharing knowledge. So currently we have some issues with understanding this value, especially if you are engineer that is working in the old-fashioned way and you are using corporate software. But hopefully, maybe a new generation of engineers will understand this value much better than the old generation.
Yeah, I'm sure about it. It was nice talking to you. You can maybe advise to the young engineers that just start in their career.
My advice would be start learning programming language because it's crucial right now. You will benefit in many ways by being able to program. And this is the problem of the whole education process in mechanical engineering. The old fashioned way that engineers are taught is using software, which requires you inputting stuff and having these 3D models, and just they intentionally leave you behind from programming because programmers now can develop tools for you and sell it for you. But being engineer and being always eager towards finding perfection, finding better solution, you must release yourself from these tools and start programming stuff. And I would say take a look at Python, take a look at programmable CAD systems. Currently, I'm using one which is called CAD Query, which is very cool. I wouldn't talk much about this, but tune your mind towards being open, using open tools, and always try new stuff.
Cool. Okay. I will find all of those and attach to the video, and maybe you can share with me the useful sources for
Sure.
the engineers so we can help out with that as well. Okay. It was nice talking to you, and I'll talk to you a little bit later about the next steps, what we might do together to help
Okay.
out.
The same to you. Thank you.